Okay. It took to me some time to set up the cool stuff. And let me clean the blackboard, because you know, when you take videos, then if the blackboard is not clean, it remains forever on YouTube, the proof that I'm not cleaning the blackboard before teaching. So that's to avoid it. So, and today we speak about what you see there, assessment of human impact, and the PowerPoint which I'm showing is available already on my website, so everything is there. The topic is, I think it is extremely interesting, but at the same time it's a bit complicated to deal with. It's extremely interesting because it's strictly related to sustainability. And I'm focusing on human impact on water resources, but when we talk about human impact in general, the topic is a bit controversial. And it's controversial because actually it's not easy to decipher the human impact on the environment in general. And also on water resources it is a bit complicated. And it's a bit complicated because the human impact is extremely complex. In general, it is positive for our point of view. It's positive because, of course, there is a general interest by humans to make environment more comfortable. And this is a general interest, and regardless of what is the personal interest, there is, of course, a general interest in making our social life more easier, and therefore our action, if you make a synthesis of the actions of humans with respect to environment, in general they are actions aimed at providing a more comfortable context, everything that we do. So even when we do something that we believe it is impacting with negative sides, but if you look at the main reasons why we do this, like for instance traveling by car, the main reason is that we find it more comfortable. And in fact, very often we are told that in order a policy to be effective, in order a policy to be effectively and positively received, we need to emphasize what is the effect of the policy in terms of ease of our everyday life. Everything we do, as I said, in general has a positive meaning. Of course, there might be some actions that are wrong, but in general, as I said, if you make a synthesis, the effect is positive. So even if you think about river training, it's conceived in order to make the environment more usable by humans, for agriculture, for settling down, for urbanization, etc. And of course there are downsides. So the key question is then to determine what are the downsides. By assuming and by taking into consideration that, of course, the main motivation that brings us to modify the environment is positive, but the effect on the environment, the actual effect on the environment of what we do is complicated and complex. So it's not easy to understand what are the implications, and above all, it is very difficult, still very difficult, to quantify them in technical terms. We are fully aware that there are implications of what we do that are negative. Like, for instance, we know that CO2 emissions are likely to induce a climate change. But then when we have to quantify these effects, when we have to translate these effects in technical terms to support engineering, to support design, it becomes very complicated because we don't know how to do this. And if we make an example which is very popular, that is climate change, we are aware of the fact that climate change has an effect on water resources, but when we have to quantify it, it's a problem. We are still debating on that. When we have to set up policies for adaptation to climate change or mitigation of climate change, the debate becomes controversial because there are no guidelines, there are no technical results that can support us. And this makes the argument and the topic complicated. Nevertheless, I thought that this is extremely important to speak of, to discuss with you, and I thought that it's extremely important to try to provide these technical guidelines that are still missing. And this is important that you take into consideration. For sure, when we speak about assessment of human impact on water resources, there is not a consensus on what is the effect of the human impact and how to mitigate it. There are a few examples of actions where the situation is clear, but these are only a few. I will make you some examples later. These are only a few. The great majority of the impact that we provoke on water resources is still under debate. Under debate means that, as I said, we are still missing technical guidelines, but for this reason I thought it is important that we try to set up together something that gives a contribution. This topic that I am presenting and the web page, it's something new. I couldn't take it from any source. And it's something that I tried to elaborate, basing on some experiences that I had, and basing on some personal reflections. It's important to make this clear. What you find here, what you find in my webpage, has no references, or the references are very reduced, because I couldn't find anything. And I made an effort to study what are the reports of the European Commission on adaptation to climate change, adaptation to human impact, but still the technical information is missing. There are a lot of discussions on the implication of climate change, what are the likely consequences, like extreme rainfall that may be increasing, and therefore the risk of flooding may be increasing, but it's not quantified. Nothing is quantified in technical terms and with numbers. So this is something that we have to explore together, and I really would like your feedback on this. First, I would like to get your feedback on the clarity of what I'm saying. So after our discussion, after these 3 hours, you will be able to provide me a feedback about the clarity. Last year, I made a similar lecture, but it was different. And at the end of the year, in the questionnaires of the students, one student noticed that he didn't understand the concept underlying this discussion. So I changed it. And I would like to get a similar feedback from you on the questionnaire, but possibly even before. Okay, the questionnaire will be taken on the last but one day of our lectures, May 28th. It's a Monday. Did I tell you already? Yeah, okay. And please make an effort to be attending that day. But please take the opportunity to discuss even today at the end of the lecture if something is not clear for you. And I anticipate to you that I would like to reserve at the end of the lecture 15 minutes to give you 5 minutes time to get together in small groups, 2-3 people, and to elaborate questions for me. And this is compulsory, so you can't skip it unless you leave the room before the end of the lecture. Okay? And this is a first opportunity for you to discuss with me and what is your feeling on today's lecture. Okay, so let's try to understand what is the concept that I would like to convey to you. And again, I'm focusing on human impact on water resources. So I'm not directly concerned with other types of human impacts. And maybe that we call them into play because they are connected to water resources. But what I'm really motivated to discuss is human impact on water resources because I have my experiences focusing on water resources, and therefore I'm more confident in what I'm saying. And first, in order to quantify, because this is our task, we are engineers, so we cannot say something like water resources are decreasing without giving any further detail. We can't say just that. We have to provide numbers, we have to provide technical guidelines, we have to say what we mean in technical and quantitative terms. So this is our task. We have to go beyond what is the discussion that we see on the media, on the TV, where they typically say what is changing, but there are no numbers in that. And when we start discussing about numbers, people get, the debate gets really interesting and complicated. So we have to try to give a contribution on that. But the first message that I would like to convey to you, the first thing, as usual, is to elaborate an idea. So you have, depending on the type of project you are dealing with, you have, and provided that you are required to assess human impact, you have to elaborate an idea. Like, try to guess, to understand, with some preliminary thinking, preliminary observation, you have to elaborate your idea on the type of impact that may be going on. And this is essential because the human impact is can happen in several different ways. So in some cases, it's very simple to understand what's going on. Like, for instance, we divert a river. And we divert part of the flow because we want to bring water to another valley. This is a typical example which happens very frequently because when we build a dam, in order to make sure that there is enough water to fill the dam, usually we get water from neighboring rivers through galleries. And therefore we design a gallery for a given flow. So it's clear what is the human impact. The river flow in the neighboring river is decreased because we are taking a fixed amount of it, fixed or variable in time, but quantified. In this case, the human impact is very clear. Okay? A counterexample is rainfall. Is rainfall increasing, decreasing nowadays for the effect of climate change or whatever? This is less clear. So the first step for you is you get a project to make, you get a requirement, a need to analyze human impact. And the reason for which you are required is very clear as well. Your project is looking forward. The project has a lifetime. The infrastructure that you are designing has a lifetime, a design lifetime. And therefore you have to guess, you have to estimate what's going on in the future during the expected lifetime. But your assessment of the status of water resources is based on historical data. And therefore, your assessment is based on the past, but you have to design for the future. And therefore, you are required to predict future changes. And what are the reasons for a change? Today, we are mostly concerned about human impact. So this is why you are required to assess human impact. This is why you are required to think about sustainability. And therefore, again, first step, you have to understand what's going on. So what is the human impact here? Is there a human impact? Yes. If yes, why? Elaborate an idea. This is the first step. And therefore, the first thing that we have to make is to try to understand how the human impact can happen. This picture is very trivial. It's an example of several kinds of human impact. We don't have much to say about it. And why we don't have much to say? Because it's quite intuitive, at least what is reported into the figure. So basically, we see here that the human impact may be of various kinds, and there is agriculture which is impacting, because sometimes we think that the human impact is impacting only when it is massive, when it is like a grey impact, urbanization. When it is a green impact, we think that it's not impacting. It is impacting. Agriculture is impacting. Even reforestation it's impacting. Now we are in the Italian lands, there is a tendency to reforestation. Why is that? Because agriculture is concentrating on some areas, becoming more intensive, and we are leaving the areas where agriculture is less productive. Typically in the mountains, in the past, there was a widespread diffusion of agriculture in the mountains, and we built terraces, you know, to make the land flat, to make the land horizontal where it was tilted. And we built these terraces, but making agriculture there is difficult because now we use mainly tractors, machines, and going with machines in the mountains is less convenient. So today agriculture is concentrating in the flat areas. It's becoming intensive and we are leaving the mountains. And then forests are coming back. And this is an impact. It's an impact, maybe positive, negative. Don't assume that, again, the human impact is always negative. Sometimes it's very positive, but still we have to estimate it. Even if it is increasing in the future, availability of water resources, we are required to estimate it. So don't have preconcepts. Don't look at the human impact as always a negative problem. There is no reason for that. The human impact is generally positive. Don't forget about the positive impacts, because they are effective as the negative ones. The same for climate change, and the media tell us that climate change is negative, always. Only negative implication. Why is that? There are positive implications. And it's important that we look at it objectively, so we don't have to be biased. If we assume that everything is negative, we are biased. And the result is that the design is not productive, is less efficient. If we are biased, the design is less efficient. So we have to be very objective. It is difficult to be objective today in a context where the human impact is generally considered always negative. If you look positive, you are likely not to be understood. So you have to be aware of that. Your role as an engineer today is a role also of contacts with people, relationships. It's not like in the past. The engineer was working into his room, giving numbers, and that was it. Today, the engineer is also required to speak with people, with the persons in the street, and explain why the engineer made some decisions. And if you look positive with respect to, you know, making a dam, you are likely not to be understood. But this is not a good reason for being negative. Okay, so let's try to understand and how it may happen. Let me go back to this picture. Agriculture, it's a human impact. And also increased infiltration, because increased evaporation after reforestation, increased infiltration after tillage. If we introduce agriculture implies tillage, means, you know, arare, and it means increased infiltration. And everything should be considered. You don't have to be concerned about it, because usually your design project is limited to a very specific case. And in most of the cases, it's quite easy to estimate what is the impact. But still, you have to start from a complete awareness. So look at this figure, and also wells, groundwater depletion, pollution, and for some reason it's not so popular today. So we don't. When we speak about water resources, everybody's concerned about climate change, but there is less concern for pollution in these times. Maybe in the future the concern increases, and whatever. The first thing is to have a complete picture and to give priorities. As an engineer, you are required to give priorities. So if you are dealing with a problem like water withdrawal from a river, and you estimated the flow duration curve, and you are required to estimate what will be the flow duration curve in the next 50 years. You have to identify what may be the reason of change. One reason is the human impact, and you identify these factors. So if you have water withdrawal that is planned upstream, this is an hard fact. So if you know that somebody may take water from the river for other purposes, this is an hard fact. So it's a human impact with high priority because, you know, it's clear that if somebody takes water from the river, it's clear that this has an effect. Climate change, is it a priority or not? You should consider the kind of river and what may be the expected climate change. This is more difficult. So let's try to guess what can be the priority and consider your uncertainty. An hard fact, which means that has high priority, is also something that you are quite confident with. If you have a kind of human impact that you cannot quantify, you should consider this in assigning your priorities. So climate change, okay, that's fine, maybe a very important priority, but I'm not really sure that what will happen into the future. So you have to consider it. Your uncertainty must be considered. If you are getting water from a river, let's suppose that you feel that river pollution may increase in the future or may decrease. This is something that indeed it's an hard fact. If you know that the water quality today is not very good in the river, so you are planning to use that water for irrigation, that's fine. But let's suppose that you are sure that they are building some sanitation plants upstream and the quality of the water will improve. Then in the future, that water may be useful for civil use, not only irrigation. This is something that you have to consider. Possibly with high priority, if you are sure that the sanitation plant will be built. And if you are sure that there is an interest in using that water for civil use. Sometimes this happens frequently. We are competing between civil use, which has the priority, and the agricultural use. So if we are designing an irrigation system, we must be fully aware that if there is a civil use that in the future that is planned, it will have the priority over irrigation. So this is a kind of human impact that if you are sure that there will be some change, needs to be considered with high priority. So, as I said, the first step is try to figure out what's going on. You need to get information, you need to dedicate to this step maybe a considerable amount of time, depending on the importance of your project, depending on the pressure that you have to estimate human impact, of course. Okay, I think I already discussed about this. Okay. There is one thing that I wanted to say, the last 2 points, I didn't discuss about it. There is a general perception that today the human impact is much heavier than in the past. And for this reason, there is a considerable interest of science and research in the human impact. And there is also geologists have proposed that we are entering into a new geological era, which is called Anthropocene, which means that it's a period of time where the life of the Earth and also the geology is starting to be influenced for the first time by humans. This is a bit controversial because some geologists say that geology is not likely to be influenced by humans. It's, the drivers of geology are of other type. One thing that I want to say is that it is indeed true that today the human impact is significant, but I am not so sure that it's heavier than what happened in the past. It may be true that today the change is faster than in the past, but I think that also, you know, if you consider how the Earth was millions of years ago, I mean, it has changed a lot, and not only in the last 20 years or 30 years. Changes were distributed in time. As I said, it may be true that today the rate of change is increased, but I think we cannot say that now. We need to, we need to wait a bit before saying that. In any case, there is one thing that I wanted to say. There is the perception that the whole globe is affected by human impact. It's not like that. The majority of the globe is still in pristine conditions. And for instance, because there are large areas which are not inhabited, like the poles, like the oceans. And of course, people who are debating this, they say that the whole ocean is changed in the last 20, 30 years because of the increase of acidification due to the increased concentration of CO2 into the ocean. This is really much debated. From the point of view of the engineer, of course it is a subjective opinion, but I would safely say that the majority of the globe is not yet influenced by the human impact. And also, there are several watersheds that still are not much influenced. But it's true one thing, the most interesting areas for living are definitely heavily human impacted, which is what is important for us, because basically as engineers we are required to work mainly in areas where people are and where people are interested and to live, and these areas generally are much impacted. So keep in mind this difference. I'm not sure that it's reasonable to say that the globe is fully impacted at all levels. I wouldn't say that, but it is for sure true that the interesting areas for living are impacted. Okay. Let's, I think I already discussed about it. Yeah, basically this slide says that there are positive impacts and that in the design of water resource systems, human impact is definitely, it plays a critical role. And this is a consequence of what I just said. So water resource systems are where people live, and where there is a water resource system, there is a human impact, and by definition. So indeed, we need to take into account it. And I'm not saying it's not important, it is extremely important. The only thing, the concept that I would like to emphasize is that we have to avoid exaggeration. This is indeed what I wanted to say. Okay, so this technical framework. And as I said, this is something new. And again, enter into a mode where you are required to provide feedback. So if you, very simple, if you don't agree, you have to tell me. If you don't understand, you have to tell me. And let's enter into a, an interactive mode. Okay, so these are the steps, in my opinion, that we have to follow. First, the perceptual assessment of the drivers. This is what I just said. You observe, you take information, and keep in mind also the opinion of people. If people think, your clients, the stakeholders, if they think that a driver is important, you are required to take into account it. Even if you are convinced that it's not, but your task becomes to make people, to convince people that your opinion is right. And keep in mind that basically when you establish this kind of relationship, when you discuss about water, water is a sensible issue, like climate. It's very sensible because, like air, because it is required water for our life, so it's very sensible. And starting from 1992, the Dublin Principles, which I didn't mention or maybe I mentioned them in my first lecture, but in 1992, the Dublin Principles were established, which are were recognized by the international scientific community and the United Nations as driving concepts for the management of water resources. And there is a Wikipedia page, which we may open later. One of the principles says that management of water resources should be designed with a transparent process. Means that you have to involve stakeholders. This is very tricky. In order to convince stakeholders that your opinion is correct, it's not just enough to say that you believe that it's correct, and it's not, unfortunately, enough to show numbers. If you show numbers, people may reply that these numbers are uncertain, that these numbers do not reflect the particular situation. And to give you an example, every time that I have to plan something related to water resources, I get the complaint from the audience that the analyses are not taking into account climate change. And therefore, my typical reaction at the beginning was to show statistics computed on rainfall or river flow. Let's say rainfall in the last 50 years, and typically I say, look, these are daily rainfall data. There is no increase in the average values and in the extreme. There is no significant change. Typical reply is, these data are uncertain. I don't trust them. Or, these data are daily data. What is changing is at the sub-daily scale. Do you have data at the sub-daily scale? My reply is no, because we don't have this data. We have data at the sub-daily scale only for a few stations. And their reply is, well, believe to me, I tell you that it is really changing. So the situation is a bit tricky. At the beginning of my experience, I was convinced that one just needs to show numbers, objective numbers. It's not enough. It's more complicated. You have to make people thinking and convinced that what you say is correct. So basically, they should gain their opinion, and they should be convinced that it's their opinion, and their opinion should coincide basically with yours. So it's not just convincing people that your opinion is correct. It is to create the situation, the conditions, so that people elaborate their own opinion and it's correct. It is a bit tricky. And I'm not sure whether I can explain well in English what I mean, but it's a different kind of, sometimes I say a leader is not the person that is able to take decision and to make the other people following this decision. The real leader is the person that allows the stakeholders to make decisions, but correct the decision. This is the real leader. So if you can create the conditions so that stakeholders decide correctly, this is real leadership. This is my feeling. Of course it's complicated. But definitely the way is not to say, I decide and this is correct. It's not enough. Even if you show numbers, it's not enough. Okay, so perceptual assessment, and then identification of objective and robust methods for assessing the effect of each driver. So let's suppose that, simple case, a driver is a water withdrawal that is projected for the future. You have to find a way to estimate it. The easy way is to look at the design, if it already exists. You estimate what can be a water withdrawal in the future through the design. This is perfect. If there is no design, you have to guess what can be the need for the future. And here we get into the technical part, estimation. And keep in mind that if you talk about climate change, this is really tricky. Really tricky. Okay, development of future scenarios. Once that you have identified these methods, you apply them. Very simple. And then uncertainty assessment. This is sometimes forgotten. It is extremely important. Today we increasingly recognize, and especially when we talk about human impact, especially when we talk about uncertain things, we are increasingly recognizing that it's important to estimate uncertainty. Sometimes we don't know how to do. It's just, in these cases, we have to recognize it. We have to say, I'm making a prediction, and I'm not sure of it. And provide as more details as possible. This is also debated. In the scientific community, there are some scientists and researchers who say that admitting uncertainty undermines the credibility. There are other scientists who say that the role of science and the role of an engineer is to say the truth, therefore presenting things objectively. You have to decide what is your position with respect to this debate. My position is for the truth. And why this? Because, you know, I think that the engineer should be really objective. And if you neglect your uncertainty, it's already a lack of objectivity. If you say, I am sure that this will happen, and you are not sure, if you don't admit that you are not sure, it's already a lack of objectivity. And think about the L'Aquila case of the earthquake, okay? Basically, what was, in an insight, the mistake? It was that the scientist said, you can go home, be relaxed, you can go home. In an insight, it was a mistake. What was the reason why they say that? Because they wanted to avoid panic, to avoid difficult situations, to avoid you know, a reaction from the population that could be dangerous. But in insight, it was a mistake. And the mistake was that they didn't say that they were uncertain of that. Of course they were. They were scientists, they knew that when you have some preliminary, you know, how to, in English, I don't know to say, but preliminary earthquakes, small, very small earthquakes,